What am I going to be talking about today? I'm here for this talk with my, my engineering hat on as part of my day job. I'm a lecturer in the School of Mechanical Engineering at the University of Adelaide, which is in South Australia. Now, before we get started on the technical stuff, to answer a couple of questions I've had from Brazilian people, and actually people from all around the world. We do have kangaroos and other Australian animals in Australia. We do not have them as pets. They're not very easy, or they don't domesticate, and they're not very friendly, actually. But we do occasionally see them in our suburbs. So on a very hot day, this was about 42 degrees earlier in the year, we looked out the window and had a little friend come to visit us. So this is a koala. And like I said, they're not very friendly, so we couldn't exactly go up and like give it a cuddle or anything like that. But we put out a little bowl of water with some ice in it, and it happily drank the water and then climbed a tree. The next day it was gone. So where it came from and where it went, I really have no idea. Koalas can only eat the leaves of about 3 varieties of gum tree, and those leaves have got eucalyptus oil. It's basically a poison to any other animal except the koala. They're an interesting creature. Now, the other question that I've had from people around the world is that I don't sound very Australian, and that's because I'm from South Australia, which was settled by people that wanted to go there, as opposed to the rest of Australia. I'm sure you know was settled by convicts. All right, so back to where we were going. Basically, as an overview of this talk, I'm going to be introducing, for those of you who might not be in a university setting, what a learning management system is. It's very obvious once you see it. And I'll talk about why I wanted to improve my life in using this thing. So it's in a very, very small nutshell. What this project involves is writing LaTeX source, converting that to HTML, and then sending HTML to this website. I'll talk about why I wanted to do that, how I wanted to put it together, and basically why it's a good idea. And some of the programming has also been done in Lua, which was really fun. All right, so to get started, I'll probably give an overview of what a learning management system is, like a live demo, a little bit later on. It depends a bit on how my timing goes. But a learning management system is kind of like Facebook, but the students log in and they can see the courses that they're enrolled in and access their course notes and see their grades and stuff like that. So was it the beginning of last year? You know, in the last year or so, the University of Adelaide switched from an old-fashioned, horrible, oh, this is being recorded, isn't it? A totally fine learning management system that we decided to move away from. And we are now using what is called Canvas by a company called Instructure. And this is a modern web program, and it has an API, which means that I can program it, which is a huge change in the old ways of doing things. So the background here is that I am the honours project coordinator for the School of Mechanical Engineering. We have about 200 honours project students every year, and I need to send them huge amounts of information that they need to know. So it's not like a typical course where I give lectures and I need to have typeset mathematical lecture notes. I just need to give them a lot of stuff. And managing all of that stuff was a real pain, and it became harder and harder to manage over the years as changes started to come through. So basically I'd heard about this tool called LaTeXML. I wanted to get used to using that, and I wanted to produce HTML and PDF. So like I said, in the old days, we used, for this course, a single Microsoft Word document that had literally everything the students needed to know in it. It contained the forms that you needed to submit to do a purchase. It had the rubrics for the assessment, had all the information about how you should do project management and blah, blah, blah. It was poorly structured and impossible to maintain, and getting information out of it was, as you'll probably appreciate, quite difficult. Let's say I wanted to circulate the rubric. I needed to open up the PDF, open up the Word document, somehow extract that information. Never had much luck copying and pasting between Microsoft Word documents, especially when formatting is involved. So that would kind of mean printing the thing to PDF and extracting the pages I needed, like just a bit of a disaster. So over time, I became less and less able to use this monolithic Microsoft Word file to manage content because things needed to be changed and people didn't know where to look for things. So slowly that information started being put online, and therefore we had two versions of the same content that got out of sync, and putting stuff online wasn't necessarily any easier to find or to update either, because you have to go to the website, log in, navigate to the right section, go click, 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 then click on the edit button, then open up the HTML view because the GUI view is just not very good, and then you find the right bit of the source and then you edit it, etc. I'm sure I'm preaching to the converted in saying that it would be nice to have a decent way of editing this stuff. So not just creating the online content, but it was really useful to have a single reference document for this course. So we didn't want to throw away the benefit of just being able to say, okay, you're a new supervisor in the school, here's everything you need to know, it's in this PDF, that's what the students get given, and you don't really need to hunt around as long as you've got that thing. So we give that to students, we give it to supervisors, and then also when we get accredited by Engineers Australia, we can give it to them as well. So it makes our life easy to have these multiple views of the content, and it's of course important to keep that all in sync. So I'll start with the bottom point here, that I very briefly considered the idea of not using LaTeX for this job, maybe writing the source in Markdown or something like that. But I also then very quickly realized that I'm so used to writing in LaTeX that I would miss all sorts of useful features, like being able to write some macros to keep things consistent, make things easy to update, and so on. So although few of my colleagues are very comfortable using LaTeX, I figured, well, this is a tool for me. If I have to hand this off to somebody, then that becomes their problem. So I'm not really sorry at all to have based this around the LaTeX workflow, and I maintain that it is pretty much the best thing that you could do in this scenario. So I have one single LaTeX source, which then produces the HTML and produces the PDF. Like I said, I wanted it to have macros in there so that I could keep things up to date. If the workshop manager, for example, changes from one year to the next, I can just update the macro, regenerate all of the content, and everything's up to date. Like I said before, in the past, I would open up some reference documentation and there'd be the name of someone who'd left 5 years ago because we just hadn't kind of clicked through there and remembered to update it over the course of the years. The other sorts of things that I like, I guess I'm moving more towards programming, more so than just having a macro, is things like when things are due. Learning management systems are pretty dumb across the board. I don't know about if any of you teach in a university, but for me, we would say things like, oh, that deliverable, let's say it's a report, is due Friday of week 11. Make sense? Do you think these learning management systems know what week 11 is? Not a chance. So you need to put in a specific date. I haven't actually done this yet, but I'm thinking with this LaTeX approach, I'll be able to do some sensible things by calculating certain dates in the semester and so on. Then weightings of assessment is something we always like to tweak a little bit. Sometimes we'll sneak something in and it will add a 5%, and we need to take 5% away from stuff. Again, that's something that needed to keep in sync, and that's, again, something that macros can help with, etc., and so on. Now, I was a little bit wary of the fact that I like to produce, well, I'm known to produce relatively ad hoc solutions to things, and the last thing that I wanted would be to get to a critical point in the semester and then realize I'd come up with some clunky tool chain that just was fragile and didn't work that day. So I was pretty hopeful that I could use a tool that was being actively developed and I could basically not have to worry about its reliability. So that led to the investigation of which LaTeX to HTML tool I should use. like I said earlier, I already basically had a horse in this race in that I had wanted to investigate LaTeXML. So actually, to be honest, I didn't really seriously investigate any other options. I gave it a go and it worked, and so that's been good. For the purpose of this talk, though, I did look into what is currently being developed, and there are 4 kind of obvious candidates in this area that seem to do quite a good job of trying to produce arbitrary complicated HTML from arbitrary complicated LaTeX source. So TeX4HT is the mainstay in this area. I guess it's been the longest in development and perhaps the most flexible. LWarp is written in Lua, and I know nothing at all about it except that it has a 951-page manual, which I find quite amazing. My understanding is that it uses a similar mechanism as TeX4HT, but without going via the DVI route. I don't actually know how that works, but because they're using Lua, who knows? Lots of magic is possible. Then LaTeXML itself is written in Perl. It's not provided in TeX but it's very easy to install. So if I'd tried to install LaTeXML and run into any hurdles, I probably would have just given it up. But you can clone the repository from GitHub, run make install, and it's all fine, at least on my Mac. So the last one is, I guess you say, Heveya.
Not so easy to install.
I'm glad I didn't try. But the documentation did seem, I think I saw a 2008 stamp on some of its documentation, so it does seem to still be, at least in use by its author, if nobody else. Now, I figured actually that the choice that I made here wouldn't be too important. If I needed to switch from one translator to another, then pretty much everything else should work around that. Now, I do have some assumptions built into my workflow on the particular kind of output that LaTeXML gives me, and I'll show you an example of that. So I wouldn't just be a 3-second change to switch, but I'm pretty confident that if a new or a better LaTeX translator came along, then I'd be able to switch. So LaTeXML itself, I can sketch a little bit of an overview of how it works. Now, I'm only a user of the system, so I really haven't delved deeply into its core functionality. It appears to do a good job of re-implementing TeX within Perl. So it will take arbitrary TeX code, not LaTeX, but TeX code, and run through a tokenization process emulating TeX itself. And so it can do a fair amount of programming that you would have written in TeX that just works as part of the processing to HTML. So it doesn't need to kind of pretend to emulate that programming that you might have written. It actually executes that code as if it was TeX. Now, I was a little bit curious about how general this re-implementation of TeX process was. And half an hour ago, I just tried to see whether it would use, whether it would do anything sensible with XII. So if you're not familiar with XII.tex, it's a very clearly written TeX file by our friend David Carlisle, and when you execute it, if you haven't seen this before, oh dear, sorry, I needed Arara installed. Arara. It produces something very nice. So the question is, does LaTeXML emulate that or not? Now, I have the wrong terminal window open. So to run LaTeXML, it's just a kind of a complicated one line. And, oh, I did the wrong one. Apologies. You can see it's running, it's doing some things, no obvious problems. I quite like that as a diagnostic. And the post-processing appears to have worked. So the question is, oh dear. I thought I'd be really clever and try and separate everything out, and then now I've lost myself.
You can look at the HTML file.
Here we go. So,
Oh,
wow, look at this. Here's the PDF, sorry, the HTML. It has processed xii.tech and produced the right thing.
wow.
And there's even a little footer at the bottom there telling us that it generated it from LaTeXML.
Wow.
So that's pretty cool.
Yeah.
However,
The name is misnomer. It's TeX.
say again.
The name is a misnomer. It's
Oh,
TeX.
it could be TeX to ML for sure, but it does attempt to emulate LaTeX packages as well. So what it doesn't do, however, is it doesn't load up each style file and then execute all of the underlying code. I'm not exactly sure why that is. I suspect that it doesn't make sense in a lot of cases to try and do that. So for example, here with loading example3 and then trying to use some example3 code, which is just TeX code, so it should be able to do the same thing. I'll skip you the demo. It just doesn't work. We come here and, okay, it says, I don't know what expl3 is, I don't know what expl syntax on is, and then because of that, it then doesn't do the correct thing afterwards. So it wouldn't be impossible, my understanding, to actually make this work, but it's questionable whether you would need to.
It didn't even try to look at it.
It didn't even try, which is arguably the correct thing to do, because if you're loading a package like geometry, for example, there's no point in executing all of that page layout code. So instead, for the LaTeX approach, it would say, oh, I'm loading the geometry package. There might be one or two commands in there which it tries to emulate, and then the rest it knows that it doesn't need to execute. So I can see why it doesn't do that. But anyway, let's get back to where we were. So of course, this made me very happy because I wrote a very simple LaTeX test case, put in some macros, and it worked. So oh, that's promising. Let's continue. I should mention, because it's written in Perl, you need to, if you want to support extra packages, you need to write Perl code. And that was the point at which I just sort of, my eyes got a little bit squinty and I didn't proceed any further. I found that the combination of LaTeX, Perl, XSLT, HTML, and CSS all bundled together was just a little bit too complicated for my brain. The way that you run it, I already gave you a demo of this, so it's relatively straightforward. What I have is a single file, which is called Honors Project Handbook, and I run this command on that, and it sucks in the files it needs to. It then creates HTML5. You can choose other varieties of XML or HTML as well. And I'll discuss this in slightly more detail. It doesn't convert each TeX file by file. It reads everything in as it's going, so an input will just put that content in there. You can see there's a couple of lines here saying split at chapter and then split naming equals label. So what that does is it creates separate HTML files based on the actual the location of the chapters. So the way that I've got this set up is that there is oh, I thought I had another slide there. Maybe I didn't. One-to-one correspondence between my TeX files and the HTML files, but it doesn't need to be that way. So that's the kind of the architecture that I can create HTML. That's a good starting point. Now, just for the curious, I wanted to introduce the Canvas programming interface, and this is not something that I have a lot of familiarity with. It uses what is a so-called REST API. I didn't know what that was, so I went to Wikipedia. It says, REST-compliant web services allow the requesting systems to access and manipulate textual representation of web resources by using a uniform and predefined set of stateless operations. And I still don't know what a REST API is. But basically, it means you can use the program curl. You write some simple commands. You get JSON output from it. And you just basically go to their API reference document. And you can, with a bit of trial and error, figure out how to put data in there and get data out. So there's an example at the very bottom there where I've skipped my secret API token, which allows me to not put in my password for obvious reasons. And then there's the URL, which is basically where you go to log into this website and you put some stuff on the end. And this particular example here will give you a list of all the assignments and the properties associated with them, like when their due dates are, how much they're worth, etc. You can also upload a file to Canvas using this interface. And I wrote this late at night, once upon a time, and I do not remember how it works. So this was before my exploration with doing this kind of work with Lua. And so you can see that it's a pretty ugly bash script. The gist here is that you need to send you need to post data to the website. It then sends you back a URL, which you then need to follow. I think the two-step processes for security and so on. But that sort of works. So what this allows me to do is that once I've compiled this PDF, I can, as part of the workflow, upload the PDF into the system so that the students have access to this PDF and it's kept in sync. If I had to upload that manually, then chances are I wouldn't, or I'd forget to. So like I said, it started with one-line curl things. I had a bash profile, a whole bunch of bash functions in my .bash profile file, and that got me a little way. Started to write that a little bit more in depth, like you saw with the file upload, and then I've recently switched to doing this in Lua because I'm not crazy. The only reason it took me so long is because I haven't done this type of web programming with Lua before, so I had to look up how to do it, and you know, there's only so much inertia you can overcome. But at a certain point, it became necessary for me to do real programming on this stuff. If you ask the Canvas API for, let's say, a list of all users, it doesn't spit you out a JSON file with 200 entries. It gives you 10, and then it says, please ask for page 2, and then you iterate. Doing that sort of iteration was not my idea of fun in a bash script. So that was really the impetus to get me to use the Lua programming, and of course, it's very good. It got me looking into the Lua package ecosystem, and I'm happy to say that package proliferation is not just a problem in the LaTeX world. So I searched for JSON decode or encode, I think, in the Lua Rocks website, and I got probably over a dozen different packages that can turn a JSON data into a Lua table. To be honest, I don't even know which one I ended up using. It just works, so there was no problem with that. What I should have done, I think, halfway down there you can see there's one by Lua Rocks. I figured since the ecosystem is called Lua Rocks and there's something by, that would probably be the authoritative one to choose. Oh, better luck next time. So in Lua, this is what it looks like. You need to install an OpenSSL package because that obviously doesn't come out of the box. And with something very similar to the curl request, you can do the same thing. You get the JSON data, then a single one line of code transforms that JSON data into a Lua table. Then you can do all of the regular Lua sort of programming. So I found that really enjoyable, as opposed to programming in Bash. So once I had all of these pieces into place, I needed to actually glue them together. So I'm just aware of time. This will go pretty quickly. What you get from LaTeXML is intended to be a standalone HTML set of pages. And that's actually not what I wanted, because I needed the snippets of HTML that I could be uploading into the site. So I start off with some LaTeX source. Like I said, input various files, and they get translated into HTML. And like I said, I set this up so that there was a one-to-one correspondence between the text files and then the generated HTML files. And that helped with the kind of the automation of it. As part of that, a table of contents gets generated. That needs slightly different processing, but that's a bit of a boring story. What you end up getting with each one of these HTML files is some top matter, which you don't care about. Some bottom matter with a footer and so on. You saw that generated file earlier said created by LaTeXML. I also do not care for this. And then the content is very nicely machine-generated HTML. So it's easy to even using simple tools to extract data from. So you can see this is far more organized than a human would ever write. Actually, I added all the indentation here just to make it a bit easier for us to see. So what I needed was everything between section and section, which is shown here. There's a title, then there's the content, and a reference to this tool was brought up earlier. I use one line of awk code, which eventually I'll replace with Lua, but I don't think I can do it in one line of Lua code. So this single line will take the full HTML file, then snip it down to just the bit that I need. In terms of images and files, I don't have too much to say here. Because I can upload these things into the website, I can put images into the PDF and then have them replicated in the HTML file. Similarly, if I need them to download a particular PDF or another type of file, I can kind of do that linking. I'm not doing this in a very clever way at the moment. Really, after the compilation of the whole document, I should generate a list of all the files that I need, check if they're on the web server, and then upload the ones which are missing. At this point, I'm still doing things pretty manually because that sort of stuff doesn't change very often, so I don't need to automate it at this point. The uncertainties that I have around what I've built, and this is very early days really. This year has been the first, so we start our academic year in March, and so this is the first year that I've been using the system. It doesn't really, LaTeXML supports maths really nicely. It has a variety of workflows which it can use depending on what kind of output you need. But in Canvas, it's still a little bit uncertain how this web app, if you want to call it that, will handle mathematics. We know that they're working on mathematics support as we speak, and so it would be a little bit premature to try and figure out the best way to do that now. Of course, that's really important if people want to take this kind of a workflow and then use it for real course content, where they're putting up, let's say, a week's worth of lecture material with equations and so on in there. Of course, I want to work through and get rid of all of my bash scripts because they're not very portable and a bit fragile. And of course, that involves moving to Lua extensively. Then really what I'm not too sure about is how much effort I should be putting into writing an actual wrapper around this Canvas API. I feel like a couple of people have mentioned you want the simplest thing that works, and that would be a bit of an overreach in terms of this work. So exactly where it stops, that's what I'm saying. I'm not sure how much development I will need to do here. Whether LaTeXML is the right choice, well, it works for the time being, so far so good. Like I said, the Perl layer is pretty foreign to me. I've never actually learned how to program in Perl, so while it looks foreign, obviously it does a really good job of processing tech macros and so on. So that architecture appears to be well designed and function very nicely. The XML output it produces is obviously very flexible. And I could write my own XSLT transformations on that XML, but really just taking the HTML and snipping it down is enough. There are some sort of questions about how we should do LaTeX to HTML conversion in the future, and we certainly don't have enough time to discuss that here. Of course, when you say that, oh, we've got this program written in Perl, why don't we, we could just write that in TeX itself, couldn't we? Maybe. So, this was really all I had to say. So I have a couple minutes to do a live demo, but in short, we changed platforms at our university. This allowed me to programmatically put content, and I hate that saying, by the way, like content sounds so impersonal, but give material to my students in a way that actually made sense. So LaTeX source, there's one truth for where all of this is coming from, and then that gets split off in various ways for HTML or PDF output, and then with a fair amount of automation, it just gets pushed through. So what is really promising to me is that LuaTeX has provided us with a cross-platform scripting solution. Maybe I don't have time. this cross-platform scripting solution is very easy to get started with. I've never used a programming language like Lua, which is so easy to use as a beginner. It has very few surprises and it's very nicely designed and elegant. I would say that even if Roberto wasn't sitting right in front of me. In terms of a live demo, do we have 1 minute, 2 minutes? Great. Now, of course, the students are actually able to log in and see all of this as we speak. So I shouldn't mess things up too severely, but
They're sleeping.
they're students, so who knows what they're doing. All right.
That's the right time for programmers to be.
All right, now. So this is the view of everything, really. This very top file is the source of the document. You can see everything is being input here. I don't recall why I used input and not include, but that's how things go. And so each TeX file just looks like a regular TeX file. It's got a chapter heading, and then we go from there. So, oh dear. Apologies. Autocomplete always tricks me. So this is the learning management system. I click through to my course. And so the students can see stuff that I put here. So this, what I call the handbook, is linked from this front page. And this is now LaTeXML generated content. So let's say we click through to the technical writing section. This is one of my favorite areas because I get to complain about the way that students write, like using the word utilize instead of use. But that's a story for another day. So you can see this is the live site that the students have access to. If I come into my TeX source here and take a bit of a look, what did I say that was called? The writing. So I was talking about utilize and use. How about we decide for the day that since we're in America, we can use American spelling. Utilize and use. That's how the Americans spell it, isn't it? Now, okay, so having made that edit, I think I saved it. I simply run my run script. It takes a little while. LaTeXML is not super speedy, but this isn't something that really needs to happen that quickly, so no drama. And because it has to process the entire document, even though I've only edited one file, it still does need to run through the entire thing. So it's read everything in. It's now building the XML, doing the post-processing. It may have a couple of, it says no obvious problems. That's good to hear. And if I run put, which is just sort of a thin wrapper around some code to make sure that it doesn't upload anything it doesn't need to, shows me a diff of what it's uploading just in case I made some terrible mistakes. And if we go back and rerun this, hopefully it worked. Utilize versus use. So as part of that, I can now run typeset. It does the PDF or actually ZLaTeX because I want to have a nice font for my students. The students never appreciate it, but it makes me feel a bit nicer about the whole thing. Can you believe like fourth year engineering students don't know the difference between a serif font and a sans serif font? It just baffles me. So here's the PDF. And yeah, so I am super happy with this approach. It's allowed me to actually improve the way that I deliver this content to the students, which and do it more efficiently than I used to do it. So that's kind of the most important thing at the end of the day. Thank you for your attention.
two questions. First, are you going to, okay, is the stuff publicly available somewhere, maybe on GitHub or so on?
That's a really important question. I haven't even put this stuff in version control yet, but once it is a little bit more tidy, I do plan on putting it in our university has a GitLab installation, and so it'll be available under a Git repository through the University of Adelaide.
And outside?
Sorry, go on, please.
And outside for the public?
Oh, and of course, outside for the public as well.
Okay.
And so, you know, it won't be very useful if people don't have access to Canvas and so on. But the LaTeXML side of things, I'll try and keep it separate so that it's pretty clear what's going on.
And second question, I understand that whoever uses this workflow should start with authoring in LaTeX. So it's basically for the professors who know how to do LaTeX files.
Yeah, and I mean, between you and me, those are obviously the best professors. So.
Yeah, I agree. I agree.
Any other questions?